Hello, we're here to talk about NFS. And we were going to do this last year, but I had a stroke, so we had to cancel. Before I start, I want to show you how excited we are about these bugs. But I realize it's very difficult to explain the excitement you get from bugs to an audience that actually appreciates policy talks. So instead, I'm going to show you a video that illustrates the excitement level. If I can find it. Okay. So yes, that is basically how we feel about NFS. So I'm going to start with some disclaimers. First of all, everything we say here is on our own opinions, does not reflect views and opinions of our employers. And second of all, we love BSD, and we use it pretty much everywhere we can. We're not very good at presenting, but hopefully the content will make up for some of that. This presentation is also very different from what we normally do, so if you're expecting memory corruption stuff, you are going to be disappointed. But what we are going to show you is actually useful in the real world. So, a little bit of background about NFS. Everybody knows what NFS is, I guess, and everybody knows that it's very old and very insecure, and it has a lot of limitations. This is all well known. Also, due to the licensing of BSD, where everybody can steal their code, this means that the code has propagated to a lot of different places. So we see, during this research, we've seen the same bugs pop up in maybe 10 or 15 different operating systems. So that's very good. And one of the vendors that we did talk to considered the bugs to be unnecessary to fix because they believe that NFS works as expected. And if you read the rest of the bullet point, I guess you can figure out who that vendor is. I'm not going to name them. So, how did we get started with NFS? Well, we were looking at something completely different, but we kept crashing a lot of BSD systems, like I think NetBSD, OpenBSD, and FreeBSD fell over all within a couple of hours. And remote kernel bugs are not all common, but they're fun and interesting to exploit, so this became the new focus. So I'm not going to go through all of this. I'm just going to ask for a show of hands if anybody's working for IBM, HP, Santa Cruz Operation, IX System, or Apple. No? Okay, good. So let's talk about some of our tools. We started the research using an old tool that's probably about 10 years now, which is a modified FreeBSD kernel that lets you route traffic through it like a normal FreeBSD system, except you can set up rules to inject faults in the traffic, so essentially fuzzing. And if you do this, NFS survives maybe 1, maybe 2 minutes before it crashes. I also wrote another tool to pinpoint some of the crashes, make testing easier, but unfortunately I lost that when I had my stroke because I couldn't get back into the crypto drive. But I have a screenshot of it. So I'm going to rewrite it and make it better. But essentially what it lets you do is open a PCAP file, run the Wireshark dissectors on it, and then go in and edit the values for the various fields and then resend it. Or you could mark a specific field as like a 32-bit integer that you want to fuzz, and then just press play, and it will keep sending the same packet with a new value until the box no longer responds. So, like I said, NFS has had a lot of different bugs. Here are just a few of the bugs that has been found in FreeBSD over the years. This is not our bugs, these are bugs before us, but it gives you an idea that maybe NFS is not very, very secure. So what is this presentation about? It is about what we believe to be unbelievable server bugs in NFS code. Unbelievable in the sense that we still don't believe that we found them only last year. These are bugs that should have been found in maybe 94, 95, that sort of time. And we're only talking about version 2 and 3 of the NFS protocol. This is not about version 4, WebNFS, client-side bugs, or memory corruption bugs. But if you want to see some memory corruption bugs, you can come to the workshop. So, traditionally, when you do a talk where you have a lot of bugs, you're meant to show some lame vendor responses so that the audience can point and laugh and feel better about themselves. But we can't do that because when I wrote this slide, we had not spoken to any vendors. Since then, we have actually done this presentation at T2 in Finland, and we did talk to some vendors before. But we're not going to share the response because we love BSD and we don't want to make them look very stupid. However, I can show you something else. That other thing we were looking at was VMS. Because about 15 years ago, we did a talk about owning VMS at DEF CON. And we quickly became HP enemy #1 and the most hated people in the VMS community. So, but 2 or 3 years ago, I decided it was time to have a look at VMS again. And since then, HP has sold off the rights to VMS to a new company who has since ported it to 86. So I decided, okay, cool. I go to the website, check it out. And they had a community license. So you could apply for a community license and get a license for free. And I tried that, and this is the response I got. To their credit, they actually did send a license in the end. So that was good. So I think you've all seen this. It's a Unix system, I know this. Yeah. But we want to go to this. It's a Unix system, and I know how to own this. So, I'm sure you've all seen the latest sort of trend in vulnerability disclosure, where people register a fancy domain name and come up with a funny name for a vulnerability. So before I had my stroke, I did consider buying nfsdoom.com and writing a raycasting engine, sort of like Doom, and have maps generated based on the file system layout, so you would run around in a maze and like shoot at files and own the box that way. And I thought that was pretty funny, but it's too much work, and I had too much else to do. Also, my hand is still not really working after the stroke, so it's difficult to write a full-fledged raycasting engine with just one hand, so I didn't do that. So, again, NFS comes in a lot of different flavors, like version 2 and 3 and 4 and WebNFS. Version 2 and 3 are the most common ones, the ones that you typically see on pretty much any internal network. So that is what we focused on. Another reason why we found them two versions more interesting is because they are supported on pretty much every operating system, including Windows, for some reason. But before we go in too deep on NFS, we need to talk about RPC and a couple of services that are required to run NFS. So what is RPC? RPC stands for Remote Procedure Call. It's some technology from the 80s, so you know that's going to be good and secure. Basically, it's a way of calling procedures in remote programs. So the client will essentially serialize and encode the arguments in something called XDR format and send it over the network to the client for the server to execute. And then it takes the return value, encodes that, sends it back to the client, so you can basically call functions remotely. It does support some authentication. Unix authentication is the most common one, but I'm not sure you can call it authentication, because essentially you tell the server, I have user ID 0, I have group ID 0, and the server goes, oh, okay, good. RPC can also refer to a sort of programming language to describe RPC functions, and then you can take the RPC specification and use the tool RPC Gen to compile C programs from RPC code. And that takes care of encoding and decoding of arguments and so on. But that's really beyond the scope of this presentation. So, credentials. Like I said, the most common way to authenticate is by something called Unix authentication, which basically is the list of the user IDs and group IDs that you claim to have, and the server trusts you. But I think of it as, yeah, you can call it authentication, but you can also call vegan meatballs or military intelligence. It's a similar thing. On BSD systems, you can do some things to make your NFS exports a little bit more secure. So there's an option called map all. And if you use that, you can make sure that every single request is mapped onto a different user. So even if the client claims to be root, the server will use like a different set of credentials, like nobody or something like that, for every single request. You can also use an option called map root, which is basically the same thing, but it only maps the root user to like a low privileged user. Sometimes you will find that credentials are host specific, so you can have a setup where the credentials are mapped to nobody for everybody on the network except for a few select hosts, which will be trusted with root access and so on. And that's kind of cool because you can use NFS over UDP, so it's not an issue to spoof a request. So that's very good. Yeah, so Linux also has something very similar, and they call it root squashing when they replace credentials for NFS. So here's a dissection of an NFS packet, and we can see the credential structure here. Unix authentication, user ID 0, group ID 0. In some implementations of NFS, there's actually an additional bug here that we don't cover, but I can mention it anyway, because not all servers, well, the server is supposed to require client requests coming from a privileged port. like it is here, but not everybody does. So if you don't require a privilege port, any user can spoof any credential and go, yeah, I'm root. And the server goes, yeah, of course you are. So what is RPC bind? Well, RPC bind is a daemon that keep track of other RPC programs and their endpoints. Example of a question you can ask the RPC bind daemon is, what port number is mount D running on over UDP, or what endpoints do you know of? I'm sure everybody here has at some point run the command RPC info-p IP address to enumerate endpoints in a pen test. So let's walk through how mounting is done. So first the client looks up mount D and NFSD, and then it gets a list of available shares from mount D. So you get a list of names like /export or whatever. Then it sends a mount request to a specific share name, and the server sends back a file handle. And that file handle can be used to navigate and traverse this file system further. So here's another interesting thing. Mount D is responsible for handing out or deciding not to hand out handles. And it makes this decision often based on IP restrictions. So often you will see that, okay, this /24 network is allowed to have NFS access, but only them. The interesting thing is that NFS daemon does not really care where you're coming from. So if you have a handle, you can use it, even if you're not in that intended network. So, yeah, so if you get a file handler, you can use it regardless of how you got it. So you can obviously try to brute force handles if handles are weak. And there is a whole list of issues associated with NFS not really caring about even attempting to validate that you're coming from the right IP, but I think I'm going to run out of time if I go into that. So here's basically what you do when you work with NFS. You get a file handle for an exported share. You use that to walk around the file system. You do some interesting stuff. You own the box, and you're done. So what are file handles? Well, a file handle is basically just a unique identifier for file system content, like files, directories, links, and device files, and so on. And it's worth mentioning that some previous work has gone into investigating weak file handles on Linux, FreeBSD, and Solaris. There's a paper out that you can read if you're interested. So, but what actually is a file handle? It's just an opaque piece of data, usually around 32 bytes. And it consists of two parts. First, you have a file system ID, identifies the file system. And then you have a file ID, which is a unique component in that file system, like a file or directory, whatever. And yeah. So, but how are they generated? Well, it depends on the operating system, on the file system, and a lot of different things. But on FreeBSD or BSD, and if we're assuming FFS, which is probably the most common file system, the file system ID will be generated by taking the name of the file system, like FFS or MS-DOS FS, and a sequential number, and then throw that into a hashing algorithm, and out pops like 16 bytes of random data. Other implementations, like I think HPUX uses major and minor device IDs. So that's not very hard to guess. And the file ID on BSD and FFS is based on the inode number plus a 32-bit random number. Some operating systems only use inode numbers. And those are great because that makes it very, very, very easy to guess. So let's talk about NFS daemon. So on the next slide, there will be a list of procedures that you can call in NFS. And if you look at it, you will see that it kind of closely matches the sort of things that you would expect to be able to do with a file on Unix. So you can access, read links, read files, write files, create stuff, make directories, create symlinks, make device files, and so on, rename. So the lookup procedure, this is good. So the lookup procedure takes two arguments. It takes a file handle for a directory, and then a file name within that directory, and then it looks up some information about that file and returns it, including the file handle for that file. So what happens if you do a lookup on ... Well, in most cases, a file handle is returned. So here's some outputs from the tool that will be released during the workshop. And this is run against a sort of modern version of Linux. So it's not going to be too interesting. But first, the mount command is issued. So mount, we're trying to mount /nfs/data, and we receive a file handle. So take that file handle, and then we do a lookup on it, and try to look up ... And it does indeed return a file handle, but unfortunately, if you look at it, it's the same file handle we passed into the function. So it didn't traverse back up the file system. But if we try the same thing on OpenBSD 7.4, which I believe is the latest version of OpenBSD, yeah, but it works on 7.5 too. Yeah, so yeah, this will work on the latest version. So we try to mount /nfs/data, get a file handle, and then do a lookup on the file handle with ... And this time we do get another file handle back. And we take the new file handle and do a lookup on that again with ... So basically what we've done now is we've tried to access /nfs data, but 2 levels up. So we've done basically cd ... cd ... And then finally, we do a read dir command with the file handle for the top level directory, and this is the root directory of the OpenBSD box. So they fucked up a little bit, maybe. They claim that it's supposed to work that way. So I've tried this on a Apple box too, OS X, and it's similar to Linux. They do return a file handle, but they only return the file system part of the file handle. However, they don't have that 32-bit random value that the other BSDs have, so they only use the inode number. So you just pick inode number 2 and you get the root directory. And yeah, FreeBSD is vulnerable to this as well, and NetBSD, and Dragonfly BSD, and I think pretty much every operating. Well, we'll see later. I think there's a matrix showing vulnerable systems. Yeah, so I'm almost done, but before I go, I just want to say, if you're good with NetBeans, IDE, and Java, please come see me later. Or if you have Hercules working with ZOS, then I want to talk to you. Or if you're hiring and you're open for remote work. So here's the matrix showing vulnerable operating system for this particular vulnerability. So you can see all the BSDs and a lot of undisclosed ones. Yeah, I should just say that it is kind of embarrassing that OpenBSD is more vulnerable than OS X and Linux. But of course, it doesn't count because Theo thinks that NFS is supposed to work this way, so it's not a bug. So yeah, it's me done.
Well, yeah. Testing. Can you guys hear me? Yeah. So it's getting a bit better. But, thank you, Christopher. So yeah, they introduced something called Redirectory Plus in the mid-90s, just to be able to return more information about a single object, pretty much like the stat system call. And if we print out all these values, you can see it's very similar to a long listing with LS. Except for the values to the right, we have a file system ID, file ID, and the file handle itself. File system ID is always 0 for the root file system. File ID is the inode number. And the complete file handle in this case is returned from OpenBSD. Yeah, you already figured this out. But if you run a Redirectory Plus towards Ubuntu, it will actually zero out the file handle for the parent directory. And if you do the same on OpenBSD, it will happily provide you with a file handle for the root directory of the exported file system, which is very convenient. So if we update this matrix, you can see that it's all spread all over the place. What's important here is that if you look at the Linux versions, the Ubuntu, you can tell that they did pretty much the same thing as BSD back in 16, while it's implemented in the Linux kernel, so basically it's an older Linux. Now, if you're a manufacturer and build stuff based on old Linux releases, you should keep track of those. I consider you to be responsible to keep track of the changes and update your products, okay? Just keep that in mind. So just a quick look at Chiron, and we can tell that it's more than 150,000 NFS servers on the internet. Very brave people. China seems to like this, but yeah. Just to give you a rough idea of people not using it only locally, but also directly on the internet. Okay, so be able to play along with NFS. We wrote a tool, a standalone, like a command line-based binary. It's a static binary, so you can happily move it around. It implements pretty much everything, with a few exceptions that's not really applied to our use case. We focused on being able to sending messages which fit in a 1500 MTU payload to be able to, use single packets. So we can just swap over and use raw sockets and have implemented some IP spoofing as well, because it's more convenient to access exports that's not really for your host or the place you are working from. On top of that, we added some feature commands to be able to put get files and stuff like that. You will see this in action. This is the command line options. Nothing fancy, but this is the way it looks. If you come to the workshop, you will get a copy and play around with this towards virtual machines that we will give to you. Now, this is the help command. It will print all the implemented commands. And what's interesting here is two things. You have on the top, you have the explore command, which is actually a really nice command that helps you explore an NFS server, and you don't have to know anything. You just run the command, and we will show you later on how it actually tries to traverse and provide you with useful information. The other thing is the make node command. Make node is a traditional Unix command to create device files. And if you're as old as me, the first thing that pops into your mind is, can you create a dev.kmem file? And the dev.kmem file is read and write access to kernel memory. That's really, really neat to have. Basically, it's an old thing that could be considered a really great rootkit API. Today, the access is kind of limited because it has been heavily abused. But we encourage you to try to create device files over NFS, in particular dev.mem and dev.kmem. And you will be surprised what you can do, especially if the server is configured open, so to speak, that they actually provide root access. That's going to be really funny for you. OK, so file handle is a different topic. So we will just see how OpenBSD handles file handles. Each OS handles them differently. And we will just talk about OpenBSD for a little while. First of all, it's stated in the manual that file handles bypass directory access restriction, which means that if you have read access to an object which is represented by a file handle, it will not assemble the path and see what kind of access you have to that file, which allows you to get access to the file itself. Looking at the or object, at the OpenBSD structure, the only thing here that's unknown to us is the random 32-bit value. And there is an advisory where all values were known that lists kind of interesting attack vectors that you can use in those cases. Today, 32-bit randomness is not really enough. So we wrote a tool to brute force the file handle, which is kind of a general tool, so you can tune it to fit and target your favorite OS. It takes just a string of hexadecimal characters, and you replace the nibbles that you want to brute force with a question mark, and it runs through them. It has a receiver thread and a sender thread, and you can run it reliable, so it expects a response, or you just flood packets away. So what's important here is that it takes roughly 75 hours to run through a 32-bit unknown, which is pretty much nothing, considering a file handle lives as long as the NFS server lives. So unless you reinstall the NFS server, I don't know if it will recompute the randomness. It will do when it generates the file system. So it's a long time, and you can split it up, and yeah, whatever. Gonna do a quick demo of the tool just to show you. How it works. So in this case, of course, you need to have like a pattern of the hexadecimal string to be able to replace the values that you want to brute force. You get a copy of this tool at the workshop as well if you want to play around with it. So in this case, we target the .136, and we have provided a template, and we run it in flood mode, so it won't require a specific response. It just has one sender thread and one receiver thread, and the receiver thread would happily print all the file handles that's discovered. So if you run this forever toward the system, you will eventually have a lot of file handles to play around with if you wait for a while. It takes, in this case, 20 bits take 50 seconds. And there's the first file handle, and we will see what that represents. So we use the tool. So the tool we wrote just uses file handles instead of paths. So it's really convenient to play around with the NFS server. In this case, it was the root file system. OK, so just to show you the command line tool we did, we put together like 2 demos. Now we know that BSD users are not stupid. No BSD user will ever export a folder that resides somewhere on the root file system. Okay? But there might be manufacturers that actually rip the code, build products, and kind of miss this. But just to make a fun demo, if someone does this mistake, this is what's going to happen. I can run the FreeBSD now, and we can do the OpenBSD on the workshop. It takes a few minutes. It's like kind of old school. Reminds me of the late 90s. So in this case, we have .20, .137 that exports share private to the host .20. And as you can see, we have .1, so we're not really allowed to mount this export. First, we resolve the mount port. And we try to run the mount command. Yeah. Can you see that? Yeah. And you get a permission denied because we have the wrong source IP. So now we use the IP spoofing to spoof our source IP with the given device just to get access to the export. I mean, this is really a nice way to get access to embedded devices and such, to get a shell on them. You will be surprised how many that actually implements NFS. Well, you wouldn't be surprised. But so this is one way to achieve that. OK, now it works. So we get a file handle for share private, and we use redirector plus to see. Yeah, and we get the file handle for the dot, the parent directory, and we traverse upwards. And finally, we end at the root file system. And in the case of FreeBSD, we have two choices. We can create a cron tab file. We can create an @jobs file. So in this case, we're going down to the var directory, to the @jobs directory. And we simply just create a job to be run in the future. And on FreeBSD, it's based on the file name to be run. So the timestamp when to execute the command is in the file name. So we need to compute that as well. So now we found the file handle for the jobs directory, which is empty. It's the lowest one. And now we compute the file name. This demo is a bit old, so it's actually a timestamp from March. Still works though, but yeah. Then we modify the UID to suit our needs and upload the jobs file to the directory represented by the file handle and provide the permissions that we wanted to have, the file name and then permissions. FreeBSD is a bit picky about the permissions and ownership and stuff like that. OK, this is the contents of that jobs file. It will run a binary or a command called bin shell in the same directory. So we just upload a simple bin shell to the same directory. We'll execute permissions. And we'll list the contents just to show you that it actually, everything's uploaded. Now we just have to wait for the @job to kick in. And we get a shell. And we'll list. And we'll list the contents just to show you that we're on the same box. OK. OK, just talking about network area storage manufacturers. I looked for a list. The only list I found was this one from Wikipedia. It has like a list of 65 from 2008, and I can bet there is quite a few more of them today. It shows you roughly the amount of manufacturers that actually implement this network area storage. So imagine we have looked at like the 3 biggest manufacturers and configured NFS on them. And the thing is that what they do is that, of course, they're not always limited and in their thought process and export folders on the root directory. But what they do, they export folders below the root directory of the exported file system, and then they store metadata in the root directory. So if we look at 3 different manufacturers, the first one looks like this. I've X'd out some stuff to make it a bit harder to see who the manufacturer is, because not everybody has responded to us. And in this case, volume 1 is backup is exported. And if we mount that, we get a file handle, and then we can see that all the backup files. But it also allows us to traverse upwards, and we get actually access remotely to the system folder, the root file system of the NAS. In this case, we have, for example, very open permissions on certain files, like homes. So you could probably update or upgrade an authorized key file. Yeah, and you can see you have access to the whole folder. Looking at the second one, we get pretty much the same thing. In this case, you have /public. Going upwards, we end up with having homes. We also have a web directory where you can upload PHP files, to execute code, and so on and so forth. And the same goes for the last one as well. We have archive and an Xout name. And you can see in this case, it's pretty similar. It has open permissions to read and write them to the web directory and the homes directory. So you will get a remote shell on these machines remotely. OK, so the explore command, imagine that you actually, just for the purpose of demonstrating the explore command, imagine that you actually have you're a cloud provider, and you provide templates for your customers to use. And those templates have default root access to NFS directories. This is what it will look like then, if we would guess that. If you run the explore command towards a live system. So the explore command does a lot of things automatically for you, so you don't have to think or do anything. You can just read the output. I scroll back and see what happened. But basically what it does is it resolves all the file handles for all the shares, and then it tries to traverse them upwards to find the root directory of the file system. And then it looks for certain files, such as the shadow file. In this case, since we have root access, you can dump the shadow file. You can also list the contents of the home directory of the root user. And you can see that we have an authorized key file that we can upgrade to have a better content. OK? OK, so first of all, I mean, this is probably leftover design issues as many other things, such as, for example, LD preload and telnet, blah, blah, blah. But the thing is that if you export, in this case, like M directory, it's not obvious for everybody that you actually provide access to the whole file system. At least you can generate a warning if you have an export file that look like that. But as many other does, you should probably zero out the dot value for the parent directory and not provide that if you are not exporting above. OK? So final note about memory corruption stuff. So we've actually been running the fuzzer towards a lot of different systems and being able to crash them remotely. We will provide you with proof of concept code to crash OpenBSD in 3 different ways, client and to server, if you come to the workshop. And this is how it looks, basically. You can see that there's a lot of unstable implementations. And if you run the fuzzer and the tools that we provided you towards different systems, you might discover the same thing. This is what the different OpenBSD crashes looks like, which you will find out if you come to the workshop. So if you have any questions, we can take them now, but it would be better if you come to the workshop, and we will provide you with a USB stick, and you can fire up the virtual machines, and we can talk while you set up your laptops. So we will be happy to answer your questions there. I don't know how we are in time, but yeah,
we're good.
Yeah, okay. So anyway, this is everything we have. So thank you.
So if you have questions, the microphone's at the front. Walk up and speak.
Hello, thank you. You said that the vendor response to it was essentially it's supposed to work like that, regarding being able to get up to the root from anywhere. Did they offer any kind of mitigation like, well, you should have just exported it in this different way, you should have set these other options, and then that would disable that? Or is it literally they intend that any NF export gives you root?
So if you look at the Linux implementation and you look at the Linux manual, they've actually handled this, and it hurts me to say that because I'm a true BSD fan. I run OpenBSD everywhere. But they have actually thought about this. So they don't allow you to, you can limit the export. And that response was from one particular developer. So, yeah. No, there is no suggestions, no mitigations, but
okay.
Yeah. So no nothing. We think the least you can do is print a warning. Yeah. Okay.
Yep, thanks for the talk. By the way, I'm from Netcraft, and I can confirm that FreeBSD is dead. My question is, do you think any of these vulnerabilities will be exploitable from a VM guest that has a NFS file share from the host?
Well, I think a lot of things. What I know is differently, but yeah, I'll say that one. We can talk about that in the workshop.
Hi. Thank you for the great talk. I just wanted to make sure I get it right. So basically with NFS, if you want to share a folder, it's called exporting. And
yeah, it's not sharing, it's exporting.
Yeah. So basically with these affected vendors, if you enable NFS and you export the folder, meaning sharing folder, somebody can leak the file handle to the ... and then keep doing it and keep doing it to get to the whole file system, basically.
In many cases, yes. So you should only export folders residing on file systems that you want to export the whole file system for. Yeah.
Okay. Oh, got you. Thank you. Yeah. Thank you so much. I appreciate it.
Any other question? Oh. Okay. I hope I see you at the workshop. We got 20 USB sticks, so first come, first serve. Thank you again.